So taking a look at this question, which is based on the ellipse from the state examination sample papers for junior cycle graphics. And the question states, shown on the right is a dimensioned drawing of the toy skid steer. The curve ABC is an ellipse, AC is the major axis, BD is the minor axis of the ellipse, and the line LM is a tangent to the ellipse at the point P on the curve. Given the major axis AC and the minor axis BD below, draw the ellipse, and using the dimensions given, complete the drawing of the toy skid steer. So as the question states, the first place to start is with the ellipse. Now on the question paper you were given the minor axis and you were given the major axis. So whether you want to use a Trammell or the concentric circles method, my recommendation for this is to use the Trammell method because it will save an awful lot of construction in here, and particularly when you're drawing the construction of the tangent to an ellipse at a given point. So we start off by making a Trammell where we mark a point P at the end of the piece of paper. You take half the major axis and mark it on the Trammell, put the point P at the end of the minor axis and then take half the minor axis. So you have your point P and half the major axis marked on the Trammell, point P at the top of the minor axis and half the minor axis marked on the Trammell, and then lining up the 2 points with the axes and marking off the points of the ellipse at point P. Work your Trammell around the curve, producing the ellipse. Now this area that we have in here where we have the wheels, you can see that it is not a good idea to heavy in the ellipse here until these wheels have been drawn. So the ellipse is a continuous curve in the upper half, so you can heavy in all the ellipse up here, but just draw the ellipse lightly down here until you know what points, you know the exact position of the circles. Now, once you have the ellipse drawn, right, using your Trammell, the next thing would be to work out the tangent. Now, you cannot just draw a tangent to an ellipse. There is a construction associated with it. And the construction to get the tangent to an ellipse at a point on the curve is as follows. Just going over here to the question. In order there to get the point P, which is the point on the curve, if we look at the information from the end of the major axis, you can see we have to measure over 25 millimeters to get the center of these circles here. But this red circle here has a radius of 10. And from the end of this circle, you can see there, from the diameter of the red circle, we can see we have a line extended up until it intersects the ellipse there at the point P. So that's how we get point P on the ellipse. So measuring over 25 brings us to the center line for the circles. And then measuring over another 10 millimeters gives us this point here. And I extend that point up until I get point P on the curve. Now, once you have point P on the curve, we're now ready to start the construction for a tangent to an ellipse at a point on the curve. And this is done as follows. When it comes to any ellipse question, you first of all have to find the focal points. So using your compass, put the point of your compass there on A and take half the major axis on your compass. Half the major axis on your compass, and then place the point of the compass here at B, and we swing an arc onto the major axis that locates F1, and we swing another arc onto the major axis and that locates F2. That's how you get the focal points. Half the major axis on the compass, and you can either use the top of the minor or the bottom of the minor, swing an arc onto the major axis to locate points F1 and F2. Once you have F1 and F2 located, we join F1 up to P and back to F2. That gives us an angle up here at point P, and that angle must be bisected. So we take our compass and put the point of our compass on P, and any radius, it doesn't matter what radius you use, we swing an arc. Where that arc intersects the line going from P to F1 and from P to F2, where that arc intersects here, we swing an arc from there. And where this arc intersects this line, we swing an arc, and where the two arcs intersect gives us a point that is equidistant from that line and that line. So when you join that point through P, that will split the angle in two. So we draw in the bisector, and that bisector is the normal. And then we set up the line LM at 90 degrees to this line. So looking in at this here, once you have the bisector achieved, you draw the line LM at an angle of 90 degrees to the bisector going through point P, and that is our tangent. Now, we do not know where this tangent ends, so draw it in lightly first, and then we'll go back to the drawing. Now, if we look at the drawing, we can see here that the width of this is 15. And we can also see that if we bring a line up from A, it'll give us the end of the tangent there at L. But in order to find M, we have to draw this vertical line that is 100 millimeters high, and then measure in 15 millimeters inside that, and then draw this vertical line here to get M. So there's the line that we talked about from C, a vertical line up from C, and I measured up 40 and 60 to give that line there a length of 100. Then inside that line, as stated in the question, I came in 15 millimeters and draw another vertical line there to get M. And that gives me the end of the tangent on that side, so I can heavy the line up to there. On this side, all we do is very simple. We extend a line from A up to the tangent, and that will give us where the tangent here ends at L. And this line can be extended down onto the base that we have based the drawing on. So that then completes that area where we have our ellipse drawn, we have the tangent drawn, and we have those two lines. This line here coming from L down, and the vertical line going up to the top here, and measuring in 15 millimeters to locate M. Now, to get this portion of the cab, looking at the drawing, we can see here that if we extend this line up from P, that this line is an extension of that line up until it hits this horizontal line at the top. And then to get the front face of the skid steer, we draw a line from F1 up to that point where they meet. So again, just to highlight that, it's up 40 and 60, which is a total height of 100 to get this horizontal line. So we've measured up 40 and we measure up 60, and we draw this horizontal line. Then using your set squares, we bring point P up vertical onto that horizontal line, and that locates that point there. And then once we have that point there, we join that back down to F1, and that gives us this line, which is going to be the front of the cab. And just to be technically accurate, that cab would be continuing through, so there would be just a tiny portion that you would see there, even though that's not indicated on the drawing. This circle up here is radius 15, as you can see in the question. It says there it's radius 15. So with that point as center and setting your compass to radius 15 millimeters, we draw this quadrant or this arc until it intersects this line here at the front, and that then completes that portion of the cab. So now what we have is we have the cab drawn, and we also have these lines here. Now in relation to this line here, we know it starts in this corner, but just in relation to getting that point there, if you look at the question, you can see there that we have B, and this line comes over from B to locate that corner, and the distance here is 15. So we extend our line over from B, we know it's on that line somewhere, then it's 15 millimeters out from that line, we measure out 15 and extend that line up to meet there. That's the point we're looking for, and then join from here down to meet that. Be important to put in that line first before you draw the cab, so you don't have the cab extending into this area where it's not needed. The bucket is straightforward enough in the fact that the top of the bucket here is level with the major axis. So what we do there is we know that that distance is 15, and we're told in the question to measure out 15 there. And then from here down to the bottom, this is a diagonal line, and the bottom here is 65. So you measure out 15 there in line with the major axis, and then from the bottom here, the bottom of this line, measure out 65, and then you can join all of those points together, getting your bucket. And then finally, once all of that is done, the next thing that we need to do is just get the circles. And you can see here that this circle is out 25. Now that 25 distance will give you the radius. If you are measuring from here back 25, that means that the distance from there to the center is 25, so that the radius is also 25. So what we have to do there is we measure back 25, and then the center will obviously have to be up 25. So once you've done that, you've come back there, you're 25 millimeters and up 25, and do the same thing on the other side. So here we have it there, that from that point we measure back 25 millimeters and up 25 millimeters, and that's the center point for this circle, radius 25, and we can draw this circle here. The inside circle is radius 10, so just change your compass there to radius 10 and draw the inside circle. And likewise with this one here, extend this line down to the bottom, measure over 25 and up 25. That will give you the center there, and you draw the outside circle radius 25 and the inside circle radius 10. Once those circles are in position, you can then continue the bottom curve. All of these points that I've used there with the trammel are not relevant, but what I can do is I can use the points that I've had there. That curve would be heading to that point, and likewise here, this curve would be heading to that point. We do the same thing on the other side, and then once that has been completed, that is that question completed. So once you have the ellipse drawn, right, and when it comes to finding all of these points, all of those points can be very easily found by just accurately following the measurements. The difficult portion of that question, and the one thing that you need to know, is the construction of a tangent to an ellipse at a point on the curve. And again, just to go over that, you need to get the focal points first of all. So half the major axis on your compass, put it on point B, swing an arc onto the major axis to locate F1, swing another arc onto the major axis to locate F2. Then join F1 up to P and back to F2, gives you this angle up here. You need to bisect that angle, put the point of your compass here on P, swing an arc, and where that arc intersects that line, swing an arc here. Where the arc intersects that line, swing another arc, and where the two arcs intersect, draw a line through P. And then the line LM, which is our tangent, will be at 90 degrees to that line. And you draw that, and once you have that done, the tangent drawn and the ellipse drawn, the rest of the question is very, very easy if you just accurately follow the dimensions that have been given over here in the question. That completes question 6 from the state examination sample paper, which is the ellipse.